Hello everyone, I am Ashley Butikofer and I am presenting my remote sensing term project on the urbanization effects on the Co-op weather station. This semester I have been working on a project in the Utah Climate Center documenting microclimate differences between two weather station locations. The Utah Climate Center maintains a cooperative observer program weather station, which is part of a national network of weather stations associated with the National Weather Service. And data has been collected from this co-op station for 130 years at various locations on USU's campus. And just a few years ago, the Utah Climate Center actually received an award for the consistent data record. However, the current location for the co-op station doesn't really fit the standards from the National Weather Service because it is very close to the parking lots and buildings. And there's been concern that the impervious surfaces surrounding the station are contributing to an urban heat island effect on the temperatures. And as you can see in the pictures here to the right, the co-op station is surrounded by parking lots and buildings and gravel and very minimal vegetation. The data from this station is used to verify forecast models when big storm systems pass through the valley, as well as tracking climate change in Logan, Utah. And as we all know, campus isn't slowing down its growth and construction, so the Utah Climate Center proposed a new location at the Logan Country Club golf course. And if at any point in the presentation I mention USU or co-op, these pictures right here, this is the location that I'm referring to. And this is the golf course location, which is the site that they propose to move the co-op station to. And as you can see here, there is an ag weather station that has been installed, and that was done to kind of prime the move for the co-op station. Being that it is located on a golf course, there is abundant vegetation around the station and also minimal impervious surfaces. So this is a better fit to the National Weather Service standards. And it's also unlikely to experience urbanization in the future because it is a golf course. For this presentation, I will be documenting the microclimate differences over time between the two sites. And I will be focusing on how urbanization has changed in the areas surrounding the two locations by looking at the NDVI and also how the surface temperatures have changed at both sites. I will also complete some analyses to see if the NDVI has a noticeable effect on the surface temperature. And the overall objective is to determine if this location is more suitable according to the vegetation and surface temperature properties. Alright, here's a quick overhead view of the locations. Here on the left you can see the USU Co-op station. This is the Nutrition and Food Science building, so it's just northeast of that. And over here is the golf ag weather location in the middle of the golf course. And you can see they aren't very far apart. They're just over 1,000 meters apart. And the golf course is about -3 meters, so 3 meters below the USU Co-op station. For this project, I used data from Landsat 5 and Landsat 8. The co-op station was placed in its current location in 1985, so I wanted to get data from that year to 2022. I clipped areas of 530 by 570 meters around each station in order to get a good representative area. As far as the figures go and images, I produced NDVI and surface temperature images, and then I created time series of the summer months and annual means of the NDVI and thermal bands. At the end, I took a look at the relationship between NDVI and thermal bands by creating a regression analysis. Alright, looking at the NDVI images, we can see that the area surrounding the golf course has a higher NDVI. There are some red patches which correspond to the highway and also the sparse native vegetation on the mountainside. There's also a little roadway and shed in the center of the golf course, which you can see in the NDVI map, which I thought was cool. Also, each station is located at the center of the images. On the USU Co-op station, you can see it has very minimal scattered vegetation, as you can see by the low NDVI values. At the top left, there is the cemetery, which shows up as higher NDVI, and there's also some scattered higher NDVI values to the right, and this area has some residential areas with garden space and trees. Just by looking at these images, I have the delta NDVI on the right. It seems as though the NDVI has increased over the years, but it isn't very representative to have just 2 dates of NDVI to look at. So it's difficult to tell if that's actually the case. So I created a time series from 1985 to 2022 to see if there really was an increase in the difference of urbanization between the sites. I took the NDVI values at the golf course and I subtracted the NDVI values from the USU Co-op so that the values above 0 would indicate higher NDVI at the golf course. And this plot turned out very noisy. I did apply a cloud and snow mask, however it does seem that possibly some cloud or snow pixels snuck into the data. The overall trend seems to be quite steady, but it's hard to tell with the winter months added. So the next step I took was cleaning up the data a bit more, and I decided to only keep data from the summer/fall months from May to October in hopes of avoiding those snow pixels. Also, this study just makes more sense in those months when there's actually vegetation growing. Now we can see that the NDVI is consistently higher at the golf course, except for a few points here in the late 80s to early 90s. The average NDVI difference is around 0.2. You can see in this figure. On the left, you can see that the NDVI at both sites follows a similar pattern throughout the years, maintaining around that 0.2 difference. We can see that there are some intermingling data points, but overall it maintains about that 0.2 difference. And this suggests that the area surrounding the co-op hasn't really seen major changes in urbanization throughout the study period. In these figures, the data is even more simplified. I took the annual average NDVI from the summer months and plotted the time series for both the co-op and golf. And I also produced the difference plot on the right. Once again, we see similar patterns between the sites. However, it's easier to see that anomaly in the early 90s, where we have great fluctuations. It gets really, gets really low, and then the next year is really high, and then back down low in the difference between the NDVI. And if we look over here on the left plot, we can see there's a point in 1992 where the co-op NDVI increased and the golf course NDVI decreased. So it's a deviation from that pattern. Alright, moving on to the surface temperatures. These figures were taken from July of 2022. We can see in the areas of vegetation at the golf course that the temperatures are cooler than the highway area. And then on the left, the co-op has an overall higher surface temperature, and we can see a little cool spot where the cemetery is. This does show that there is a cooling effect associated with vegetation and that latent heat flux portion of the surface energy balance. The average difference in surface temperature between the two areas of study is about 5 Kelvin. Once again, I filtered the data to only contain the months May through October. And we can see that the golf course is consistently cooler than the USU locations. There's a few deviations in the data up here, but overall the pattern shows that the golf course is cooler. The average temperature at USU was 303 Kelvin, and at the golf course it was 300 Kelvin. You can see on the plot that matches the data points at a mean difference of -3 Kelvin, which suggests that the golf course is on average 3 degrees Kelvin or 3 Kelvin cooler than than USU. In the previous portions of my study, I also calculated the average differences in canopy temperature, and the maximum temperature difference was 0.4 Celsius warmer at USU, and the minimum temperature was 0.6 Celsius warmer at USU. So there definitely was a greater impact on the temperature for the minimum temperatures. Alright, the annual surface temperature trends follow a similar pattern just as the NDVI did. As the co-op gets warmer, the golf course normally gets warmer as well. In 1992, we can see an anomaly of the temperature similar to the anomaly in the NDVI for that year. And we can see that the co-op stayed. The pattern was pretty similar, but the golf course was what warmed up to create that anomaly. All right. And finally, we get a look at the summer data for the years 1990 to 1995. And an interesting thing to note, just as I mentioned, that the anomalies show higher temperatures at the golf location and not necessarily cooler temperatures at the USU location. Here in the left plot, the year 1992, we can see that the USU and golf data points are pretty close to each other, whereas the other years show a greater spread in the data. The NDVI plot also shows mostly similar NDVI for the USU area. But in 1992, there's lower NDVI at the golf course. And this could be indicative possibly of less effective irrigation scheduling during that year, because we do see both a drop in the NDVI values and a rise of surface temperature at the golf course for that year. A quick look at the regression plot shows a weak negative linear relationship between the difference in NDVI and the difference in surface temperature. We can see there's quite a bit of uncertainty in the regression line. The data is not spread very evenly. It's very clustered. We also have a very low R-squared value and a not very impressive linear regression equation. I also plotted the temperature difference against the NDVI at golf and also the NDVI at the co-op to see if there is a difference in that relationship. The co-op plot shows a pretty flat relationship, whereas the golf plot has a slightly negative relationship similar to the regression plot. And this suggests that changes in the golf course NDVI had a greater effect on the temperature difference than did the co-op NDVI. Alright, so in conclusion, the higher surface temperatures in areas with high heat storage could increase minimum temperatures by holding onto that heat for a longer amount of time and releasing it throughout the night, which could be possibly the reason for that greater difference in the minimum temperatures. recorded at the USU location. And it can also increase the effective daytime heating around the co-op station. So that's really the big reason for the study, is understanding how the surface temperatures could affect the canopy temperatures. There's also, as we just saw, there's a weak negative relationship between NDVI difference and the temperature difference between the two sites. And the NDVI at the golf course changes more over time than the co-op, which is also indicative of the lack of vegetation at the co-op. And I thought this was really interesting because I thought by using the NDVI at the golf course, I could see how the vegetation amount has changed at the co-op to kind of understand the urbanization changes. But we can see that the vegetation amount hasn't really changed at the co-op, but the health of the vegetation at the golf course has. So that was an interesting thing to note. And because of that, the golf course NDVI affects the difference in surface temperature more than the co-op NDVI over time. Overall, temperatures at the golf course may be partially dependent on irrigation scheduling and the health of the golf course turf grass. However, the urban heat island effect will be greatly reduced if the station is relocated to the golf course. And I just wanted to give a special thanks to Dr. Torres. A lot of the code I used for this project was developed from his Lab 6 time series example, and he really helped me to be able to develop the code I needed. And I also wanted to thank you guys for watching my presentation. Thank you.